Welcome and thank you for participating in today's discussion hosted by Synix Technologies. This event is on the Synix Polymorph workflow. I'm Sanjay Sangani with Synix and will facilitate this meeting along with our presenter Eric Carlson. Synix Technologies' core competencies are in scientific information management, microscale parallel experimentation and contract research. Founded in 1994 and now with over 500 employees, 1,500 customers and 70,000 users worldwide, Synix continues to develop capabilities that can keep you competitive. Our software greatly impacts productivity in the design, execution, analysis, and reporting of research projects. Results are now interpreted faster, easier, and less expensively. Synix's electronic notebook, decision support, and content solutions bring certainty to your decisions. Our benchtop automation systems and workflows accelerate the pace of discovery by transforming traditional bench science into automated parallel experimentation workflows with a solid informatics foundation, increasing experimental capacity and velocity by 10 to 100-fold. The primary areas that we work in are polymorph and salt selection, solubility determination, excipient compatibility, and force degradation. In this hour, Eric Carlson will demonstrate the benefits offered by the Synix Polymorph workflow. Eric received his PhD from Stanford University in chemical engineering. He has been with Synix for several years and is now Vice President of our Life Sciences Technology Group. While many of you are familiar with WebEx, I would like to quickly review the communication tools we will be using throughout this event. Audio participation is available through your teleconference. We will pause for questions and answers throughout the event and open phone lines. If questions arise prior to the break, please forward your questions through the question and answer window on your participant panel on the lower right-hand corner of your screen. This is a question mark icon and is only viewed by Eric and myself. Please open this window and send a message right now indicating whether you can clearly hear me. Is the audio too loud, too soft, or just right? Thank you. And with that, let's get started. And I'll pass control over to Eric.
Okay. Thank you, Sanjay. I'm going to start my presentation. One moment while I can bring up. So today in particular, I'm going to talk about crystallization, preformulations workflow, specifically doing polymorphs, salt selection, and using automation and high-throughput workflows to achieve better productivity. Sanjay's already given a bit of an overview of Synix and who we are. We're a public company with about 500 employees. We've been working since 1994 and have a number of life science customers who have been making use of our software, our informatics, and our workflows. Specifically within our high productivity research division, we have a real background in doing technology development, offering feasibility and proof of concept types of studies, offering managed services and doing managed services around crystallization and reformulation services, and deploying out tools and doing workflow deployment where we enable other people's labs with the equipment and the methodologies that we have. We have a goal of transforming scientific R&D through microscale parallel experiments. When we look to have an impact in a scientific area, we look to impact the whole process of what a scientist does, from designing a set of experiments to executing, analyzing out, and reporting. So it's more than just the automation. It's really wrapping both automation, informatics, software, and methodology around the whole process. If you compare what traditional R&D process would be relative to what a Synix-enabled R&D, there are a number of key differences. Traditional methods tend to be largely manual and very trial and error. Our methods tend to be very optimized. We use an automated workflows with advanced informatics. We tend to go to smaller scale, so if a traditional process relies on gram scale quantities, we can do things at milligram scale. It allows you to explore a much broader space or to explore a similar space at a much earlier phase in development. Largely speaking, because we're doing things in parallel, we're able to shrink down the overall data analysis time and go from hours or days to minutes or hours, and the overall getting results in a matter of days as opposed to weeks or months. And generally speaking, a particular scientist can go from doing 500 to 1,000 experiments a year to 10,000, 25,000 experiments per year, shrinking the total cost per experiment in the course of doing that. In general, we have a number of different applications that we've applied our technology, our automation, and our informatics to. They tend to sit in the development space, preclinical development. And so if you look at a cartoon of the overall development cycle, we tend to impact and bring workflows into the pre-formulation development, formulation development, process development, and analytical development. I'm going to talk today mostly about solid form selection, with a real focus on polymorph studies and salt selection, co-crystallization studies. We also have used our similar methodologies in looking at solubility for doing tox formulations and stress testing of force degradations. And I'll mention the fact that we've also had a fair bit of work on looking at organic synthesis and process optimization and doing catalysis screening with a variety of different, looking at cross-coupling types of reactions and anti-selective reductions, a variety of different types of reaction screening. We've also done a lot of work on formulation development, drug recipient compatibility studies, liquid formulation development and stability, as well as solid dispersion work, liposome and self-emulsifying systems as well. I'm going to talk a bit today about integrated workflows and what we mean by that, and we tend to take a very modular approach. So when people at CIMICS talk about an integrated workflow, what we mean generally is a workflow that includes CIMICS modules and some of our technologies, a variety of third-party equipment, typically analytics or other types of sample processing and laboratory equipment. It's a portion of our software, and I'll talk about this a bit. It's our laboratory execution analysis software. It wraps around both our equipment and other people's equipment. And we bundle all that with chemistry and application know-how to really affect an impactful workflow. These can range from smaller types of systems, which we would consider a benchtop deployment, where we have a single station with providing automation with some local software, to a full system that actually has software tying together a number of different discrete stations, both sample prep and processing, as well as a variety of different types of analytical stations as well. In general, then, we have a system that really tries to follow the process of what a scientist does. So across the top of the slide here, I talk about being able to design, execute, analyze, all the way through. We have software that supports this whole process. I'll talk about that in detail. And each part of the process, we may have different stations, and it may be CIMICS provided equipment to do powder and liquid addition, conditioning of temperature control and stirring on the robotic deck, using filtration on the deck to do and then do different crystallization processes on the robotic deck, all controlled by the software, and then generating samples that are then subsequently analyzed by Raman, XRD, and other types of analysis as well. Before I talk more details about the actual salt selection and polymorph types of studies, I'm going to talk a little about some of the platforms that we actually use to do these studies. First, one of our hardware platforms. So CIMICS has a robotic platform that we call our core module. It is similar in many ways to other types of liquid handling robots, but it's different in a number of important ways. It's a very modular platform, allowing one to build up, starting from a number of base unit operations, and configure the robot, both the deck and the arms, to have a type of capabilities appropriate for different types of applications